We're going to look at the connection between negative exponents and reciprocals. First, we have to go through some ideas that are really important with exponents. Now, right here, what number can you multiply with 4 to get a product of 1? In other words, 4 times what is 1? Similarly, what about 2/3? 2/3 times what number is equal to 1? Well, in both cases, you have to consider the reciprocal. What is the reciprocal of 4? Well, it's 1/4. 4 times 1/4 is indeed 1. How about 2/3? Well, consider the reciprocal of 2/3, which is 3/2. Now, 2/3 times 3/2 is going to be 6/6, which is 1. So, no new information here. So, we can say that two numbers with a product of 1 are reciprocals. We're going to be exploiting this a little bit later on. Also, recall, any integer or any number a to the power of 0, by definition, is 1. So consider 5 to the power of 2 times 5 to the power of -2. Well, using the the product law of powers, we would simply add the exponents. So 5 squared times 5 to the -2 is really 5 to the 0. Then 5 squared times 5 to the -2 must be equal to 1. When x is a non-zero number and n is a rational number, then x to the power of -n is the reciprocal of x to the power of n. In other words, x to the power of -n, we can move that into the reciprocal of x to the n. So whenever I see a negative exponent, the word that I attach to it would be reciprocal. Now, this is an interesting idea. When x changes from the numerator to the denominator, or vice versa, the sign of the exponent changes. So just for fun, 5/2, I'm just going to put 1. Now, whenever I see a negative exponent, I think of the reciprocal. Now, notice how 5 to the -2 was in the numerator, and then if you put it in the denominator, it becomes a positive exponent. Similarly, x to the power of -3 become 1/x to the power of 3. Now, for examples here, let's continue our argument. Now, here's an interesting idea. A squared times b to the power of -3. Keep in mind that this means a squared times another quantity, and that other quantity is b to the power of -3. And what we can see by that is that it becomes a squared. B to the power of -3 is really b to the power of 3. So a squared b to the power of -3 turns into a squared divided by b cubed, or a to the power of 2 divided by b cubed. So let's read that yellow sentence again. When x changes from the numerator to the denominator, the sign of the exponent changes. So I suppose you could argue, wait a second, b was in the numerator, so all I did was I simply moved it to the denominator and the exponent changed to positive, if you wish. So now, how would we do this? I will go about this a very long way. I'm going to say this means x to the power of negative 2 times y to the power of 3 times z to the power of negative 1. And what I mean by this is really this is 1 over x squared times y cubed times 1 over z. And if we multiply these quantities, we are going to get y cubed divided by x squared times z. And often I would take away my dot product there, and that's how it would read. Step 1, step 2, step 3. And as long as you know this foundational knowledge, you can use this idea where if my exponent is negative, and if I move it to the denominator, it becomes positive. So right away, I know that this is y cubed divided by x squared times z. All right. This is a great question. Now, recall what a negative exponent means. The negative exponent means a reciprocal. So, really, what we can do is, now I'm going to split it apart. I'm going to decompose my exponent. I could call this 2/3 to the power of negative 1 times 3. Are you with me on that? And I'm just going to put this in brackets. So, really, the exponent negative 1 means the reciprocal. So this would be 3 over 2, right? The reciprocal of 2 over 3 is 3 over 2 to the power of 3. And doing this magically, right, we can apply the exponents independently to both the numerator and the denominator. So this ends up being 27 over 8. Could choose to do it like that. All right, I'm going to have another crack at this. 2 over 3 to the power of negative 3, instantly, when I see negative exponent, that really means that I take the reciprocal. And then I simply cube 3 over 2, and that is 27 over 8. All right, I'm feeling okay with this. Oh, thankfully, we're getting to the last one. So if you want, you can try this out. And there's many ways that you can do this. So 10 over 3 to the power of negative 2. Ten over 3 to the power of negative 2, well, that is 3 over 10 squared. That is, I could take the reciprocal. 3 over 10 squared is 9 over 100. Right? Now remember, that any number a over b to a certain power of n, you could rewrite this as a to the power of n, b to the power of n. And what is interesting about this is it actually expands our understanding. So 8 over 27, for instance. Did you know that 8 over 27 to the power of 1/3 is equal to 8 to the power of 1/3 over 27 to the power of 1/3? And we know that to the power of 1/3 really means cubed root. So a lot of people have a hard time doing this right here and right here, but are really competent in doing here. with radicals, right? What is the cube root of 8 over 27? Well, this notion helps us think of it. Really, you take the cube root of the top and the cube root of the bottom, and that answer is 2 over 3. Anyways, I digress. On to the next video.